Right, it should be back in the game. Apologies about that. I don't quite know what happened then. So, right then. So I was on third. So we were on 16 times 3. So that is 48. See if I can just about get my work from before that. Okay. And then we've got 8 times 50. So 8 times 5. That would be 40, and then add the 0. So that would be the square root of 400. And then minus 5, and then 63 divided by 7 would be root 9. So that's going to give me 48 minus 20 minus 5 times 3, because the square root of 9 is 3, so minus 15. So that's 48 minus 35, which is 13. Okay. Going on to the next question now. So question 3. And this one is the curve has the equation. Okay, so question 3, just pop that to one side. And it says the following. So the curve has the equation y equals 2x squared minus 11x plus 13. The point P has these coordinates, lies on C's. Find the equation of the tangent to C and at the point P. So to do that, what I need to do is I need to work out the gradient at this point P. So I need to differentiate to do that. And then I need to use the same formula that we used in question 1, y minus y1 equals mx minus x1. Okay, so to start off, number 3, I'd always write down y equals 2x squared, and then minus 11x plus 13, and then I'd differentiate to find the gradient, so that would be 4x minus 11. And then I'd say at P, and then I'd always put it as coordinates, 2 minus 1. I might even reference by here x equals 2, y equals minus 1 for later. Something I always used to mess up on when I was doing these myself. And then I would say dy by dx equals 4 times by the x coordinate, which is 2, and then minus 11. So that is going to be 8 minus 11, which is minus 3. So what I need to do now is I need to sub into the formula from before. Y minus y1 equals mx minus x1. So that is y minus minus 1 equals minus 3x minus 2. So that's y plus 1 minus 3x and then plus 6. And then when you've got just y on its own, we tend to just leave it in the form y equals mx plus c, but you can write it all in one line, it doesn't matter. So we get minus 3x, take over the plus 1s, it becomes minus 1, so plus 5, and that would be my equation of the gradient. Equation of the tangent. So I'll just reference what that is, equation tangent. Okay, now as a rule, whenever we take the gradient of, whenever we do dy by dx, this always finds the gradient of the tangent. The normal is at right angles to the tangent, so we can use the same rules before, that the gradients have to times together to be minus 1. And for the next bit, what I need to do is, it says the point Q lies on C such that the gradient of the normal to C is minus 1/9. So I'm going to say here underneath, I'm going to say Q has normal gradient. Now let's put that in bold, so I'm just going to put it in capitals, of minus 1/9. I'm going to say therefore gradient of tangent must be 9. So you just flip that over, and one of them has to have a minus. That already has a minus. 9 over 1 is 9. And I might say as minus 1/9 times 9 equals minus 1. Okay. So from here, I know that dy by dx is equal to 4x minus 11. I've already worked that out. But I actually know what this thing here is. I know that this is 9. So all I need to do is say 9 equals 4x minus 11. Take the minus 11 over to get 20 equals 4x. And then 5 equals x. Okay. And that was question 3. Question 4, binomial expansion. So the first thing I would do in this scenario, just try and be very careful with this camera now, is I would write out that we are doing 1 minus 2x to the power 6. Because it's the power 6, I'm going to start working out Pascal's triangle. I wouldn't bother going through the formula for this. I find it easier to just use Pascal's triangle, but it's whatever you find easiest. So you can see here I'm starting to generate the rows of Pascal's triangle, and I need to go up until I go 1, 6. That's the row I'm looking for. So 1, 6, 15, 20, 15, 6, 1. That's the row I want because the power is 6. So I always look for the second number being 6. Okay, so I already know my coefficients now. That is going to be 1, and then that will be 1 because it's the first thing to the power 6, but 6 to any, 1 to any power is always 1. And then it will be minus 2x to the power 0. Then it will be plus 6, and then 1 to the power 5, and then minus 2x to the power of 1. And then it will be 15, and then it will be 1 to the power 4, and then it will be minus 2x to the power of 2. And it wanted me to go up to the first 4 terms, so that's 1, 2, 3 terms, so I just need to do one more set of terms. So that would be 20, 1 cubed, and then minus 2x cubed. So now starting to answer those, 1 times 1 and anything to the power 0 is 1, so that's just 1. Then we've got 6 times 1, but then times by minus 2, so that shouldn't be a plus, so I think it should be a minus. So that is going to be 6 times minus 2, which is minus 12x. And then it's going to be 15 times, and minus 2x squared is going to be positive 4x squared. So 4 times 15, double of 15 is 30, double it again is 60, so plus 60x squared. And then here we're going to get minus 2 cubed, which is going to be minus 8. It will go back to being a negative because it's an odd power. And then 8 times 20 is 160, so it would be minus 160x cubed plus ... It does continue, but it only wants me to go to the first 4 terms, so pointless to do anything else. Number 5 is completing the square. As it says, express 3x squared minus 12x plus 29 in the form a brackets x plus b squared plus c. So to start that off, all I'm going to do is I'm going to take the 3 out as a factor. So I'm going to get x squared, and then I'm going to get minus 4x there, plus 29. The next thing I'm going to do is start to complete the square, but with inside here. So you need to do a set of brackets in here. This is the most common mistake made with this. So you do x, and then you halve that coordinate to get 2. That squared's gone, but you square it by here. That'll generate x squared, and it'll generate minus 4x. But it will also generate a plus 4 term, which I don't want. So I need to get rid of that thing there. So you always take away whatever that is squared, irrelevant if that's a plus or a minus. And then you would start to expand this set of brackets. So I would get 3 brackets x minus 2 squared minus 12, because 3 times minus 4, and then plus 29. So we finish off getting 3x minus 2 all squared, and then minus 12 plus 29 would be plus 17. Okay. In terms of part B, it says state, using your answer to part A, write down a stationary value. So the stationary value is always whatever makes this bracket 0. So it would be stat value equals, so what makes that bracket 0? That's when x is 2. And then y is whatever's left over. So if that is 0, so that would be 3 times 0, so that's gone. It's just plus 17, so y is equal to 17. So my coordinates are 2, 17, and if you come back to the question, because it's 3x squared, that means it would be like that, so that means it would be minimum value. So I just say that and is a minimum. Okay? Okay, number 6. Right, apologies, I seem to have lost the camera again, so it might be that I have to restart the recording again. Let me see if I can fix it. Okay. Excellent. Right, I know how to fix it now. Okay, so for question 6, I've got a website for you to go and look at if you want to have a little bit of further understanding on this. So I'll write that down as well in a second. So we've got x squared plus 2k minus 1 x plus k squared minus k plus 2 in a bracket equals 0. So basically we get these graphs just like the one we had before, this 3x squared one that we just did, that looks in like some sort of shape like that. Okay, so in terms of what's going on here, because we've got k coming in for this x coefficient and k here, it's just saying whatever these two things are related to, whatever my values for ax squared plus bx plus c, it's relating, the value for b is related to c by using this constant k throughout. If you go to www.bit.do, just make sure I write it. Now you must write this case sensitive, so May 2012, and then Q6. If you type that into the internet after this, you can actually see exactly what this graph looks like when we actually start giving some values for k, and you can see exactly what's going on. And it says, show that it has no real roots, whatever the value of k. So say that k was 10, so if I had like x squared and then plus 19x, because I would have subbed in that's 10, and then whatever that is, so 100 take away 10 plus 98, show that it's got no real roots no matter what. So I need to use a discriminant for this. So the discriminant, I pick out what my values of a, b and c are. So a's coefficient is 1, b is 2k minus 1, and c is all of that last thing there, that k squared minus k plus 2. So if I put it through b squared minus 4ac, now because it is because we're saying it's got no real roots, that means that would be less than 0. So that would give me 2k minus 1 squared minus 4a, so that'd be 4 times 1, and then times by c, so that'd be k squared minus k plus 2. So this thing squared means times by itself, so I'm just going to write that out to make things slightly easier to expand it, and 4 times 1 is 4, and then that would be that. Okay, so less than 0, less than 0. Okay, so this thing expanded out is going to give me 4k squared, and then it is going to give me 2k times minus 1 would give me minus 2k, but then 2k times minus 1 would also give me minus 2k, so give me a total of minus 4k, and then minus 1 times minus 1 would give me positive 1. And then expanding this out would give me minus 4k squared, minus 4 times minus 4, minus 4 times minus k would give me plus 4k, and then minus 4 times by plus 2 would give me minus 8 is less than 0. And you'll notice there that we actually have a couple of things that are the same. So we've got 4k squared, take away 4k squared, well there you go. Then we've got minus 4k plus 4k, so those two both cancel out. But then we've got plus 1, take away 8, which is minus 7. And minus 7 is less than 0. So what I wrote down when I was doing this, I said, as minus 7 is less than 0, it is true. And basically, no matter what the value of k, can you see that these k's will always cancel out when we use algebra? Say, as k's will always cancel. Always cancel. It doesn't matter. Let me write cancel a bit better there. Will always cancel, and basically because of that, it's irrelevant. Your answer will always be minus 7, which is less than 0, which means that you will always have no real roots. And if you go to this address here, you can actually see what the graph looks like, and you can manipulate the value anywhere from minus 100 to positive 1,000,000 if you want to, and it will always be the case that it doesn't cut the x-axis. Okay. For part B, we are given 3x squared minus 7x. Sorry, I'm looking at the question below now. 3x squared plus 16x minus 12 is greater than 0. Okay, so you would have done these at GCSE. It's just a case now that we're looking at inequality rather than being equals like we used to think at GCSE. It just wants an inequality. Still exactly the same methods apply. The way we do it is that we do 3 times by minus 12 to get minus 36. And then it must add to whatever this number here in front of the x is, so positive 16. So think of a pair of numbers that times together to give me minus 36 and add to plus 16. So for me, that is plus 18 minus 2. And just double check. Yep, that makes minus 36. Yep, that makes plus 16. So the way I do it is that I drop just the squared from the 3x squared, and I put that greater than 0. And then I put in plus 18 in one, and then minus 2 in the other. But you will notice that this obviously isn't true, because 3x times 3x gives me 9x squared, and I'm supposed to have 3x squared. What you must do if you use this method is you must cancel down. So we get x plus 6, because I've divided both of those by 3. And then we get 3x minus 2, because nothing does cancel down in that second bracket. Very, very easy way to check now if I'm right. 3x times x is 3x squared. Plus 6 times minus 2 is minus 12. So I feel pretty confident that's looking good. So if I was to solve this equal to 0, I would know that x equals minus 6 or x equals 2/3. You still use that knowledge. You still use that. So when you've got a quadratic, it's like a U-shaped graph like that. It is crossing the x-axis in 2 distinct points. I know what those 2 points are. One is minus 6 and one is 2/3. And I am interested in where that graph is greater than 0. So it's greater than 0. All over here it's greater than 0. And then all over here it's greater than 0. Okay? So basically when x is less than minus 6, or, it's important that you say or, not and, x is greater than 2/3. Okay? Okay, so the next question is differentiation from first principles. Definitely going to come up, always comes up, always very, very similar. The more practice, the better that you do, especially around the time of the exam. So we're told that given that y equals 3x squared minus 7x plus 5, find dy by dx from first principles. So the way that you do that is that we're basically looking at a curve, and we're saying we've got a point on the curve here, and then if we take another point on the curve, the closer it gets to being that point there, the more it will resemble what the tangent to that point is. So this is what differentiation is basically. So we say that y plus a little bit of y, so we call that delta y, would be equal to 3x plus a little bit of x, all squared, minus 7, and then x plus a little bit of x, and then plus 5. Okay, you then expand out the brackets from here. So this x, I'm just going to work this out over here, a little bit of a side work. So x plus delta x squared means that, which would give me x squared plus x delta x plus x delta x plus delta x all squared. Now I put that in a bracket just so it's not like it belongs to just the x, and then that will give me x squared plus x delta x plus x delta x, so that's 2x delta x, and then plus delta x, all of that squared. Okay, times that thing by 3 here, so that is going to be 3x squared, and then 3 times 2x would be 6x delta x, and then it would be plus 3 delta x all squared, minus 7x plus, no, it wouldn't be minus 7 times plus would be a minus 7 delta x, and then plus 5. Okay, so from here, what we do is we just do simultaneous equations. We call the first equation number 1. We call the last thing I've done where I've expanded out equation 2. And we always do equation 2, take away equation 1. And it goes back to that first question where we said dy by dx is the difference in x's divided by the difference, the difference in y's divided by the difference in x's. So we've got y plus delta y, but then we want to take away y. So basically what you do, if you see anything that is in equation 1, you cancel it from equation 2. So that 3x squared goes, that minus 7x goes, and that plus 5 goes, leaving me with just 6x delta x plus 3 delta x all squared minus 7 delta x, and that was, sorry, delta y here, delta y equals all that. Okay, now I can see there's a constant going through every single one of these terms. I can see that delta x is in every single one of them. So I'm going to do delta y divided by delta x. So I'm dividing this side by delta x, so I need to divide that side by delta x, would be 6x plus 3 delta x minus 7. Okay, the final thing you do is very, very important you remember the statement. We say dy by dx equals lim, as this point here gets even closer, as delta x tends towards 0 as it gets closer and closer and closer, of this delta y over delta x. So dy by dx is equal to, now that's got no delta x in it, so just 6x. And that has got delta x. Now that's going to 0. 3 times 0 is gone, so it just disappears. And then minus 7 goes here. Okay, very, very repetitive. Absolutely guaranteed to come up. Comes up every year. You need to learn the theory. Okay, 7b. So to do 7b, I need to take everything. So it says 2/3 x to the quarter plus 12x. Right, I've started to answer it. I'll write it properly first. X to the 3. Now, what you must do to differentiate this with respect to x, you need to take this out of anything that's not an indice form with just a normal number. We don't like this x over 3, so we change it to plus 12 and then x to the minus 3. Okay, now we're differentiating with respect to x, so when you say differentiating with respect to x, we say d by dx, but we're used to seeing it as dy by dx because usually it just says y equals, and then d by dx times y is dy by dx. So what we get here is we get the power you times by the coefficient, so it's 2/3 times by 1/4, but then that power must decrease by 1. You need to have that saying on loop in your head. Times by the power, reduce the power by 1. So 1/4 take away 1, or if you want to think of it as 1/4 take away 4/4, would be minus 3/4. It is absolutely fine with a 2-mark question to leave your answer in indice form like this. You don't need to take that down to the bottom. You don't need to write it as the 4th root cubed. It's fine to leave it as that. Then we would get plus 12 times minus 3. So 12 times minus 3 would be minus 36. But then that power must decrease by 1. So minus 3 take away 1 is minus 4. Okay? And then can we cancel anything down here? So yeah, anything that's in the top that's in the bottom, 2 and 4. So divide both by 2. So that becomes 1 times 1, which is 1. And then 3 times 2, which is 6. So 1/6. And then this would be x to the minus 3/4. And then I would have minus 36, x to the minus 4, and that's that bit done. Okay? Okay, so for question 8a, we are told solve the equation 6x cubed minus 19x squared, and then plus 11x plus 6 equals 0. Okay, so usually they tell you to start with f of something. In terms of this case, we've got to try and solutions is there'll be 3 solutions because it's a cubic. Squareds, graphs always have 2. So from here, actually what I just said is not strictly true. It depends how many times it cuts the x-axis. So you can have a cubic that does that. So that would have 3 solutions. It goes in once, twice, 3 times. But you could have a cubic that does that. So that only has 1 solution because it only crosses the x-axis once. And you could have one that does that. So that's got 2 solutions. So pardon me. Right, the way that you do this is that you start to just guess a number. Okay, so we're going to guess like x equals 1 or x equals 2. I'd always start off with x equals 1. So we say f of 1. So we do 6, and then you just change the x for 1. And wherever you see x, you change it for 1. We're looking for this to equal 0. So I'd work this out underneath. So that's going to be 6 minus 19 plus 11 plus 6. So 6 plus 6 is 12, plus 11 is 23, take away 9. No, that's clearly not equal to 0. You don't actually have to say what it equals to, as long as you reference that it's not equal to 0. So the next one I'm going to do, I could try -1 here, but I'm going to try for 2, f of 2. And then I do 6, 2 cubed minus 19 times 2 squared, plus 11 times 2 plus 6. 2 cubed is 8, 8 times 6 is 48. Minus 2 squared is 4, times 19 is, right, 19 times 2 is 38, and double that is then 76, plus 22, plus 6. So if we take the positives, 48 plus 22 is, add the 6 is 76, and then 76 take away 76 is equal to 0. That's all good. So we know that x equals 2 is one of my answers. So I can just see that you can't see what I'm writing here. So x equals 2 is one of my answers. So from there, how I would actually get that back is I would say that x minus 2 equals 0 goes into, or is a factor of, this thing up here. So you just basically take it over. So whatever this one is here, you always say that x and then the opposite sign to it is a factor. So the way that we've been solving them is that we say x minus 2, and then we're going to start trying to work out what must be in this other bracket. Okay, so looking up here, we know we've got to make 6x cubed. So x times what makes 6x cubed? Well, that'll have to be 6x squared. So you can always work out that one, and you can always work out the end one. I've got plus 6 overall, minus 2 times what makes plus 6, and that has to be minus 3. Okay, now from there, you can either choose to get the x squared the same, or you can choose to get the x's the same. I'm going to choose to get the x squared the same, but I can realize that some people would say, well, you get plus 11x, it maybe makes it slightly easier. So the way that I do it is I know that minus 2 times 6x squared would give me minus 12x squared. And I know this is going to be something x. I don't know how much x, and I know that when that times is by it, it will give me something x squared. But as I've already highlighted, I know altogether I have to make minus 19x squared. So minus 12, and then what makes minus 19? Or if you want to, take minus 12 to the other side and add 12x squared. That would leave me with minus 7x squared. So I know what that is now. So x times what makes minus 7x squared? Well, that would have to be minus 7x. Okay? So a second, I'm just going to check that's fine. Yeah, and the way that I could check it if I wanted to, I could see if I can make plus 11x from it. So the way I'd make plus 11x is I would do minus 2 times by minus 7x, so that would give me plus 14x. And then x times minus 3 is minus 3x. So that would give me 14x minus 3x would give me 11x, which is what I wanted from above. So what I must do now is try and cancel this bracket down. So we do the same trick as before. So we times 6 times minus 3, which is minus 18. And we do the minus 7 for the plus. So we're looking for a pair of numbers that times to minus 18 and adds to minus 7. So that, by me, is minus 9 and positive 2. So then solving this one here, I would get x minus 2. And then I drop just the squared term from 6x and put it in both, but I must cancel down because obviously 6x times 6x will give me 36x squared, and that's not the case. One bracket I'm going to put in minus 9, one bracket I'm going to put in plus 2 from up here, and then I get x minus 2, and then cancel down this bracket, so I get 2x minus 3, and then here I would get 3x plus 1 equals 0, so x equals 2, x equals 3 over 2, or x equals minus 1/3. Okay. Okay, last bit now on the home straight now. So transformation of graphs. So this is number 9. And you have this original graph here. And it looks something like that. And you're told that is... Oh, 1 second, sorry. You're told this is minus 6, 0. And you're told this is 2, 0. And you're told this minimum point here is minus 2, minus 7. So it says, can you draw A is f of x minus 5? Now that's really easy when it's given that it's just a case of plus 5 or minus 5, or if you've got 5 f of x. if you've got f of x plus 5 or f of x minus 5. When it's outside the bracket, it does what you expect to the y coordinates. When it's inside the bracket, it does the opposite of what you expect to the x coordinates. So that f of x minus 5 is going to do the opposite because it's inside to the x values. So that is going to move that along, not minus 5 to minus 11 from that minus 6. It's going to move it forward 5 places. So that minus 6 plus 5 will give me minus 1. So it's basically going to be exactly the same graph, just shifted, and that would be minus 1, 0. This one here, minus 2 plus 5 will give me 3 minus 7, and this would then be 7, 0. Okay. For the next one, it's inside again, so it does the opposite of what you expect to the x coordinates. So I would look at that and assume I'm dividing them by 2, but it does the opposite of what I expect. So I'm going to times my x coordinates by 2. So that is going to shift that out to be minus 12, and that's going to plus 4, and that is going to be minus 4. So it's basically just make it a bit fatter. So we're going to get minus 12, 0. We're going to get minus 7. And then 4 and 0. Okay. And finally, number 10. See if I can squeeze that in here on the last bit of page that I've got, so I might cramp my working up a little bit. Okay, so number 10. We've got y equals x cubed plus 3x squared minus 1. It says find the nature, or find the coordinates and the nature of the stationary points to C. So for stationary points, we know that their gradient is 0, so dy by dx equals 0. Okay, so what I do is I do dy by dx, which would be equal to 3x squared plus 9x, and that's it. And I can change that equal to 0 now because, oh no, I did this yesterday. 3x squared would become 6x, wouldn't it? I can put that equal to 6x there. So what I'm going to do now is just solve that. So I can see that there's a factor of 3 and x in each. So then I get x plus 2 inside that bracket. So x is either equal to 0 or x is equal to minus 2. Okay? So then I'd say when x equals 0, y equals, so I'm coming back up to this point here, y is equal to 0 cubed plus 3 times 0 squared minus 1. So y would be equal to minus 1. So there's my first set of coordinates, 0, minus 1. And when x is equal to minus 2, I get y is equal to minus 2 cubed plus 3 lots of minus 2 squared minus 1. So I'm going to take my time working that out. That's minus 8. That's going to be plus 4 times 3 would be plus 12. And then minus 1, so I get, 4 minus 1, 3. Just double check. Yeah, so, or positive 3. So there's my other set of coordinates. It's minus 2, 3. Okay, sorry, just so you can see what I'm doing. Okay, I'm just going on to the back to work now. So to determine the nature, I'll get the nature actually done up by here. To determine the nature, what you need to do to show it very, very easily is you do d2y by dx squared. You take its second derivative. You can prove it through different ways, but this is the quickest way and the easiest way, provided you remember what the rules are. So I differentiate this thing again, so that would give me 6x plus 6, and then I'd say when x equals 0, d2y by dx squared. So 6 times 0 is 0, plus the 6 is equal to positive 6. Now this does the opposite of what you expect. So when it is a positive, is actually a minimum value. And when x is equal to minus 2, d2y by dx squared would be equal to 6 times minus 2 is minus 12, plus 6 is going to be minus 6. And again, it does the opposite of what you expect. It's a minus, but that actually means it's a maximum. Okay, so over the page to draw the graph. It says sketchy, including its stationary points. So cubic graphs tend to look, oh, sorry, camera's gone again. Should come back now. There we go. So what we need to do is plot the stationary points. So I had 0 and -1 being one of them. So 0, -1, and I had -2 and 3 being the other one. So -2, 3 here. Okay, so because that's a maximum, I know it's going to look like that, and because that's a minimum, I know it's going to look like that. So basically, then I just join those up, and this shoots off to plus infinity. It tends to infinity, or plus infinity, and this one would shoot down and tend to minus infinity. It's important you include these, and it's important that you note where it crosses the y-axis, but this time it was actually one of its points was actually on there. Okay, and then finally it says write down the number of positive real roots of the equation. So positive real roots, this is a real root, this is a real root, and this is a real root. So we've got 1, 2, 3. But in terms of which ones are positive, this one's positive, this one's negative, and this one's negative because they're in the negative x values. So my answer is 1 positive real root. Okay, so make sure you keep up the revision for the rest of the holidays. If there's anything there's a sticking point, ask me on Twitter at Mr. Ashton_maths. Or ask on Edmodo, okay? But it's important that you keep up your revision little but often. Past paper every 2 or 3 days. Enjoy the rest of your Christmas.